What is the meaning of a negative vector? Well, a minus a equals 0. Vector a, subtract vector a, equals 0. So here is vector a. So which vector do I have to add to get 0? I have to add minus a. Well, if you use the head-tail technique, if this is a, you have to add this vector to have 0. So this is minus a, and so minus a is nothing but the same as a, but flipped over 180 degrees. We will use that very often. And that brings us to the point of subtraction of vectors. How do we subtract vectors? So a minus b equals c. Here we have vector a, and here we have, let me write this down here, and here we have vector b. One way to look at this is the following. You can say a minus b is a plus minus b. And we know how to add vectors, and we know what minus b is. Minus b is the same vector, but flipped over. So we put here minus b, and so this vector now here equals a minus b. This vector c is a minus b. And of course you can do it in different ways. You can also think of it as a plus, as c plus b is a. Right? You can say, you can bring this to the other side. You can say c plus b is a. C plus b is a. In other words, which vector do I have to add to b to get a? And then you have the parallelogram technique again. There are many ways you can do it. The head-tail technique is perhaps the easiest and the safest. So you can add countless number of vectors, one plus the other, the next one, and you finally have the sum of 5 or 6 or 7 vectors, which then can be represented by only one. When you add scalars, for instance 5 and 4, then there's only one answer, that is 9. 5 plus 4 is 9. Suppose you have two vectors. You have no information on their direction, but you do know that the magnitude of one is 4 and the magnitude of the other is 5. That's all you know. Then the magnitude of the sum vector could be 9 if they are both in the same direction. That's the maximum. Or it could be 1 if they're in opposite direction. So then you have a whole range of possibilities because you do not know the direction. So the adding and the subtraction of vectors is way more complicated than just scalars.